Gravitational potential energy is the energy stored in an object as the result of its vertical position or height. The energy is stored as a result of the gravitational attraction of the Earth and the object. The gravitational potential energy of a massive ball of a demolition machine is dependent on two variables, the mass of the ball and the height to which it's raised. These variables are related and can be expressed with the following equation, where EP is the gravitational potential energy in joules, m is the mass in kilograms, g is the gravitational field strength in newtons per kilogram, and h is the change in height in meters. To determine the gravitational potential energy of an object, a zero height position must first be arbitrarily assigned. Typically, the ground is considered to be a position of zero height, but this is merely an arbitrarily assigned position that most people agree upon. So if someone were to go to the top of Mount Everest, they would have a higher gravitational potential energy than if someone were to stay on the beach. If he were 85 kilograms, then his gravitational potential energy would be the height of Mount Everest, which is 8,848 meters, times by 85, times by 9.8, which is the pull of gravity from the Earth. So the gravitational potential energy of this guy is 7,370,384 joules. But this energy is just potential. If he were to jump off the peak of Mount Everest, then most of the potential energy will be transferred to kinetic energy. We can calculate his kinetic energy with the equation Ek equals a half times the mass times the velocity squared. If he was travelling at a velocity of 54 meters per second, then his kinetic energy would be 123,930 joules. But some of it will be lost as heat as well. This is why a pendulum on a clock eventually stops, because a small percentage of energy is being lost as heat with every tick.